Hi all. Today we'll be discussing on doubly reinforced beam in a building. Okay, the topic we are discussing here it is why to provide doubly reinforced beam. Okay, before that we must know what type of beams are there. Okay, especially in beam there are two types. One is singly reinforced beam. Another one is doubly reinforced beam. So here, before going to discuss why to provide a doubly reinforced beam in building, first we must know what exactly the singly and doubly reinforced is. Okay, so for that we have the representation. So I'll show you here. Okay, so this is the singly reinforced beam. Okay, and this one is second one is doubly reinforced beam. Okay, so here it is mainly why we are written or differentiating these two are because of its a depth and the reinforcement which is provided. Okay, here you can see uh, the depth of this beam is quite high as it is a overall depth. Okay, so I will be writing it is as capital D, and this is breadth of beam, and here it is also, this is breadth of beam, and this is capital D, the overall depth. Okay, generally what happens if the span of beam in any of the buildings are more, obviously based on the L by D ratio, okay, it is around 20 for the simply supported beams. Okay, based on this the depth will be quite high. For example, if 10-meter beam is there, okay, its depth may be quite high. Okay, so some circumstances you need to avoid the depth of beam, right? Okay, in that case we'll be intentionally will be reducing the depth of beam because of the unavoidable circumstances. Okay, like I will give the examples, like especially in cinema halls and function halls. Okay, there the span of the beams are quite high. Okay, even though in residential buildings also, if the hall or living room size is of more than 5 meter 6 meter like that, okay, in that case the depth of beam will be quite high. Okay, so there will be chances of obstruction of beam because of its depth. For example, if 10-meter is there, okay, if you are taking L by D ratio, if you are considering for higher spans, the L by D ratio is around 10. Okay, if you consider, you will be getting 1 meter depth of beam. Okay, as it is L by D. Okay, so small d is equal to how much? L by 10. It will be around 10-meter means how much? 10,000 divided by 10. Okay, so the depth is equal to 1000 mm. Okay, in this case, what happens if the depth of beam is 10,000 mm, sorry, 1000 mm, what happens if the span is 10,000 and L by D ratio is 10. Okay, if you are getting a 10,000 mm of beam, 1000 mm means, okay, it will be around D is equal to 1 meter depth. Okay, so you are not supposed to provide, for example, here you are getting 1 meter, but you are not ready to fix this as a 1 meter beam because of higher span. You are getting L by D, and you are getting depth of beam is equal to 1000 mm, but you are not ready to provide that one because as the building height is around 3 to 3.5 meter. Okay, if you provide 1 meter depth of beam, it will obviously obstruct the headroom space. Okay, headroom space will also get reduced, and aesthetically it will not look good. Okay, so what I will do, I'll be reducing the depth of beam. Okay, so because of this, okay, I'm not supposed to say only you'll reduce the depth, and because of this you will be getting the doubly reinforced beam. Okay, that is not the only one reason. What happens before going to the reasons? Okay, I will discuss some more part on this beam itself, that is how exactly it is differentiating. Okay, in figures also how it is differentiating, I'll show you. Okay, here this is the neutral axis, whatever the red line is there, it is the neutral axis of the beam. Okay, whereas one differentiation, here I am differentiating these beams based on the size. First one is, first difference is the depth. Okay, so here the depth of beam, this is capital D, and this is, here it is capital D. One is, okay, in a singly reinforced beam there is a, okay, whatever L by D ratio you got, you will be providing that one, so depth is quite high as compared to the doubly reinforced beam. Okay, you can, here in doubly reinforcement easily can reduce the depth. Okay, this is first difference. And second difference is what, here these are the reinforcement, this is main reinforcement, so here you will be getting what, so here we will be getting AST. Okay, and these are the anchor bars. Okay, whatever the reinforcement which we have provided at the top is anchor bars. Okay, so before that we must know, okay, this, if it is simply supported beam, okay, above the neutral axis compression is there, below the neutral axis tension is there. Okay, so here also, especially in this beam also, doubly reinforced beam also, you will be getting top fibers are under compression and bottom fibers are under tension. Okay, so this will be the scenario. Okay, whereas what happens here, the concrete in the compression zone will carry the compressive stresses. Okay, so whereas here it is, because of the reduction in depth, there is a chances of higher strain in the concrete. Okay, so I will give another representation. Before that, I will be drawing the stress strain diagram of a beam. So this is the beam. This is the depth of neutral axis, or the location of neutral axis. These fibers are under compression and this is under tension. Okay, now the first I will draw the strain diagram. Okay, here we will be getting the reinforcements. Okay, next one, here this is the strain diagram of a beam. Here the neutral axis is exactly passing through the center of the beam. Okay, so here the strain is equal, strain above the neutral axis as well as below the neutral axis are equal. Okay, now what I will do, I'll next okay, you treat whatever the L by D ratio is there, you have taken this one same as it is, the top fiber of the concrete under compression and bottom fiber of the concrete under tension. Okay, as you know, the concrete is weak in tension, so you people have provided the reinforcement, that is AST. Okay, area of steel in tension, you people have provided the reinforcement on tension side, this we written as AST. Whereas what happens, you are not happy with the depth of this beam, okay, overall depth of this beam, so what I will do, I will be restricting depth to some extent. Okay, suppose if it is D is equal to 900 mm, okay, so this is quite high, so I will be restricting depth to this much. So this is, okay, I will be restricting, or I will making this beam to 600 mm. Okay, whereas the load on the beam and the concrete grade, steel grade, nothing has changed, only the depth I am reducing here. Okay, suppose if the depth is get reduced, so what happens, okay, this will be the depth. Okay, so if it is a doubly reinforced beam, the strain diagram will modify in this manner. The stresses are well within the limit, okay, or here strain is get increased because of the reduction in the depth. Obviously, if you reduce the depth of the beam, the area will also reduce. When the area is get reduced, obviously the load over a certain area will be changed. So area is less, load is as it is, because that leads to higher stresses and that leads to a strain, higher strain. Okay, whereas here higher strain means the compressive strain is quite high as compared to tension. Okay, so I'm not supposed to compare these two, but the strain in the compression is increased. Okay, increased up at a certain extent that the concrete will not able to carry all the compressive stresses. Okay, here especially in last figure we have seen. Okay, so in this case, only in a singly reinforced beam, whatever the concrete is there in the compression side are capable to take the compressive stresses, whereas in this one, okay, there is no such chances of carrying the all the compressive strain by the concrete. Okay, so in this case, especially in doubly reinforced beam, there is a chances of failure of concrete in compression zone. Okay, so because of it's a less area, higher stresses, okay, that may be a chances. Okay, so here also I am not increasing the grade of concrete, only I am reducing the depth. Okay, because of reduction in depth we are getting the higher strain. Okay, so because of higher strain there is chances of failure of concrete. Okay, to avoid that one, okay, like as you know, the concrete is weak in tension, but even though if the compressive stresses are increased beyond the limit of concrete, there is a chances of failure. Okay, to avoid that one, what I will do, I'll be providing the reinforcement, the required reinforcement to avoid failure in the compression side. So I'll be writing it as ASC. Okay, below that we have bottom, in the bottom fibers we have AST, and in top fibers we'll be having ASC. Okay, this is all theme about singly and doubly reinforced beam. Okay, first reason is the depth. First difference is depth. Second one is the ASC. So you'll be getting ASC. Third one is higher strain. Higher strain at compression side. Okay, mainly because of three reasons. Because of reducing the depth, okay, these many things will change, and the neutral axis also vary from its original position. Okay, so always we try to make the sections a balanced one. Okay, mainly due to this, uh, we need to provide, because of reduction in the depth, we need to provide the ASC. And you may ask how to find out whether it is singly or doubly. One is it's a L by D ratio, length to depth ratio. Next one is moment. Main thing is moment. Okay, there is a limiting moment of resistance. There is a limiting moment of resistance. Okay, based on that we can easily find out if moment is actual moment, that is moment on the beam is increasing the limiting moment. In that case, okay, that will be treated as doubly reinforced beam. Okay, if it is mu less than mu limit, in that case we'll be going for singly reinforced beam. Singly reinforced beam. Okay, in this way we'll be differentiating the singly and doubly. Okay, mainly the reason behind, okay, our intention is to find out why to provide the doubly reinforced beam in building. There is no such restriction that you need to provide the doubly reinforced beam, but when you are restricting the depth, you are reducing the section. In that case, if limiting moment will be less than the actual moment, or actual moment is in crossing beyond the limiting moment, in that case you will be using doubly reinforced beam. Doubly is nothing but you need to provide the compression reinforcement or reinforcement in compression. This is area of steel in compression, area of steel in tension. Okay, these to be provided. Okay, so this is the major intention. Okay, there is no, again once I'll repeat once again, there is no such restriction is there. Suppose if the beam is within the limit of L by D ratio and you are happy with the overall depth of the beam, okay, so no need to, okay, the circumstances in is that you are not going to reduce any depth of beam, or it is not necessary to reduce the depth of beam. In that case, okay, the singly reinforcement is sufficient. Okay, singly reinforced beam is sufficient. Whereas, okay, the depth is quite high, you are not you are obstructing or affecting the L by D ratio, you are reducing the depth intentionally. In that case, if the compressive stresses are beyond the limits, beyond the limit of concrete, that means beyond the limit means if mu in is more than mu limit, in that case you need to provide the doubly reinforced beam in a buildings. Okay, I think you understood the concept of concept or why to provide the doubly reinforced beam in a building. Okay, so if you really understood, please like this video, share with your friends, and still if you are not subscribed my channel, okay, please subscribe and press bell icon for upcoming technical videos on civil engineering. Thank you.